Welcome to part 2 of graphs of functions. We are going to continue on analyzing graphs, and we'll review finding the x and y intercepts graphically and algebraically, as well as finding the domain of our graph. Some new things that we'll talk about today are the range of our graph, extrema, which are minima and maxima, mins and maxes, and then also intervals of where the graph is increasing and also where it's decreasing. The best way to analyze a graph is just through examples. So we have this graph here. It is a function. It passes the vertical line test. No one x value maps to more than one y. And so we can find a couple things about this graph when we're analyzing it. The main things that we can find are the domain and the range. Now this graph does not shoot off to infinity in any of the four directions because we can see it literally like begins and ends right at these 2 points as we go left to right. So when we're looking at our domain, we're looking left to right. Domain is x values, so the smallest x value is -5, and the largest x value is 7, and it goes that entire time. There's no gaps or jumps or anything like that. So our domain goes from -5 to 7. Now, when we write this as an interval, we have to decide, are we going to put open parentheses or closed brackets? If we look and see, does our graph actually take on the x value of -5? Is it closed? Yes. So it takes it on. So we can equal -5, and we also can equal 7. With our range, we're looking vertically. This is the y values. We look down to up. The smallest y value would be down here at -2, and the highest y value is up here at +4. We do take on those values. Our graph actually touches them, so we put those closed brackets for the range. The domain and range isn't too bad, I think, when something's graphical, when you can see it. All right, the main idea today is going to be extrema and also intervals of increase and decrease. Extrema is just the plural word for extreme. So these are the extremes of the graph. What is an extreme? It's the lowest or the highest. That's an extreme. And we have what's called local extrema, local mins and maxes. This is the plural form of minimum. There might be more than one. Or local maxima, the plural form of maximum. There may be more than one. Then we have absolutes. Your book does not use the word absolute. They just call them min and max. So I put it in parentheses. Okay, let's first look at the absolute ones. I think those are easier to wrap our brain around. So let's see what is literally the lowest point our graph hits. That's the absolute minimum or minimum. It's all the way down here. There's no point on this entire graph that is lower than the point 0, -2. So that is our absolute minimum. Then for the absolute maximum, we look and see what is the absolute tallest point that our graph takes on, and that is the coordinate point 5, 4. There's no other point that's higher than this on the entire graph. Now local is a bit more tricky. Local minimum means it's the lowest point of all points around it in a small area. And we do have to look at endpoints here. So if we take a look at this coordinate point here, -5, 1, see that in this area around it, this is the lowest point. It's all higher around this coordinate point. So this is actually called a local min. Let's see if there are more. As we go across the graph, this is the absolute minimum, so we don't need to include it in local. This might seem like it would work. However, immediately next to it, there are points lower than 3, 0. So we can't include this in a local min. If we keep going, we can see that the other endpoint is actually a local minimum because everywhere directly around it, everything's taller than it. This is a lowest point for its area. Now, you could argue also that isn't the absolute minimum also a local minimum since everything around it is taller than it? Yes, so we can actually include the absolute minimum with a local minimum. All right, let's do local maxima. So these are going to be points that are the tallest relative to their area, the highest point in its area. So we can see that this coordinate point right here, negative 3, 3, is the tallest point in its area. Everything immediately around it is lower than it. So that is called a local max, or local maximum. Let's see if there are others. There are other just local maxes, but because 5, 4 is the absolute max, it's also a local max. It's still the tallest point in its immediate vicinity. Here's an analogy that you can use to differentiate between local and absolute minima and maxima. So our town has a mayor, and here's the mayor. The mayor runs the entire town or city, and so the mayor has jurisdiction over everything immediately around it in that small town or city. However, that's the local max. That's just the mayor. The governor of the entire state is still higher than the mayor. So that's like the absolute maxima. The next main idea we're going to talk about when analyzing a graph are intervals of increase and decrease. This may seem obvious after I explain it, but basically we want to travel left to right along the graph and see where are we increasing, where are we going up, and then where are we decreasing, where is the graph going down. So it's defined as y values increasing, such as from here to here. The y values are getting bigger because our graph is increasing. However, from this point down to 0, -2, our y values are decreasing, we're going down. That's it. Now, in order to write these intervals, because we're traveling left to right, we use x values. So in this interval here, this first interval, from x is -5 to where x is -3, from here to here, we're increasing. So this is the first interval of increase. It is from -5 to -3. Then, if we keep going along our graph, we'll see that our graph falls here. We're decreasing from when x is -3 until x is 0. Then, if we keep traveling along our graph, between when x is 0 and when x is 3, our graph increases again. So that goes from x is 0 to x is 3. Then, from where x is 3 all the way to when x is 5, we actually keep increasing. So what I'm going to do is not write the 3 here. Instead, because we actually keep going, we'll go all the way from 0 until 5. Because our graph is increasing all the way from here until here. Okay. Then, when x is 5 until when x is 7, our graph falls. Our y values decrease. So this is an interval of decrease between 5 and 7. Now, a couple things. I've used this U here. This means union. It's a way to join two different intervals. And then I'm also putting open parentheses because we can't technically be increasing at this one spot. At this spot, we're actually not doing anything. It's like a split second, so we can't really increase at a spot. Instead, it's between two spots we're decreasing or increasing. So you want to put open parentheses for intervals of increase and decrease. The other thing that we talked about were intercepts. So let's talk about the intercepts. Our x-intercepts are where our graph hits the x-axis, and our y-intercept is where our graph hits the y-axis. So we can see that we have a couple different intercepts here. We have two x-intercepts. One of them is when x is -1, and the other one is when x is 3. So our x-intercepts are -1 and 3. Note, this is not a coordinate point. I'm just listing the x values, so I don't put parentheses around it. Our y-intercept is down here when y is -2. All right, here I'd like to explore Extrema a little bit more in depth. Remember, Extrema are the extremes, minimum and maximums. And this is directly from your book in section 1.6. So local extrema, local max and local mins, we say that our function f, we'll call this f. We say that this function has a local max At a point AB, so our coordinate point, if there's an open interval I, so some small interval around it, containing A, so where the point is located, for which that y value, f of A, that would be its y value, is greater than all the other y values in that interval. So we can see that this coordinate point, negative 3, 3, its y value, f of 3, or f of negative 3, which is up here at 3, is greater than all the other y values around it in some small interval I. That's why this is a local max. For a local min, it's the very exact same thing, except it's less than. We want to say that a point is a local minimum, such as this coordinate point here, negative 5, 1, if there's some interval I containing that x value, which is negative 5, for which its y value, 1, is less than all the other y values around it. It is. 1 is the smallest y value in a small interval around this point. So this is just a very mathematical way to say local max and min. And then the absolute maxima and minimum, your book does not use the word absolute, they just call them the maximum and minimum, but in math we normally say absolute. And then we say a value b, so the y value, is called the maximum if that y value is greater than all the other y values in the entire domain. So 4 would be our absolute maximum, and on the other page I called it the entire point, but you can call it this if you'd like, or you can just call it 4, since 4 is the absolute tallest y value. And we can see that 4 is greater than all the other y values in the entire domain. There's no other y value greater than 4. Similarly with the minimum, there's no y value, f of x, that is less than this negative 2 here. So that is why that is our minimum. You can write, if you're asked for the max and mins, you can either write the entire coordinate point, or you can just write what the height is, the y value, since that is the height, the max or the min. For this last example here, I challenge you to pause the screen in just a second and try to figure all of these pieces out. Try to analyze this graph on your own and see how you do, and then go ahead and press play so you can see the explanations and the solutions. So go ahead and pause the video now. Okay, our domain and range are listed here. And this was a little different from our other example, which is why it's a good challenge, but for our domain, we go all the way from negative infinity to positive infinity. These arrows pointing up in both directions are actually going out to the left as well and to the right, meaning we're taking on every single x value all the way from negative infinity to positive infinity. Our range is restricted, however. When we're looking down to up, we can see that the lowest value that we take on in the y is negative 1. We take on that value, it hits where y is negative 1, so we put brackets. We do not have a maximum y value, therefore our range goes all the way to positive infinity. For the intervals of increase and decrease, you want to read the graph left to right. And left, the leftmost x value is negative infinity, and then we're decreasing, decreasing, decreasing until we hit when x is 1. So that is our first interval of decrease, from negative infinity to where x is 1, because our graph is going down. Then when we hit when x is 1, until when x is 3, right here, we are increasing. Our graph is going up. So that's an interval of increase from when x is 1 until when x is 3. When x is 3 until x is 4, our graph is again going down. So from 3 to 4, that's an interval of decrease. And then from 4 until positive infinity in the x direction, our graph is increasing again. So our graph increases from 4 to infinity. So that's just the difference between the previous graph and this one, is that this one does have infinity involved. All right, our local minima, a point that is locally low. It looks like this is the absolute minimum. You could also argue that it's a local min, but in this case, I'll only include the local ones. I won't include the absolute minimum. So that is the absolute minimum down here. It looks like here is a local min. It's not the lowest point in the entire graph, but in its small area, it is the lowest point. It looks like it's at about 4, like 1/2-ish, we'll call that. So our local min will be 4 and then about 1/2. Then for local max, this point right here, which is almost 3,1, that's what we'll call it right here. This point is the tallest point or the highest point in its immediate vicinity, in its small interval, the area. So this is the local maximum, the coordinate point 3, 1. All right, what is the absolute maximum? What's the tallest point this graph can take on? It just keeps shooting up towards infinity. We actually don't have a maximum because no matter what point we give, you could just keep going higher and higher and higher all the way to infinity. So we actually do not have an absolute max since we're going to positive infinity. However, we do have a lowest point on the graph, our minimum. That is this coordinate point right here. Nowhere on the entire graph is there a point lower than at 1, -1. So here's the two ways you can write this. You could write it as 1, -1, or you can actually write what the lowest point is. It's -1. So I will accept either one. If you want to put coordinate points, great. If you want to just write what the actual minimum is, that's the y value. All right, so domain as a review is your x values left to right. Range is your y values down to up. Intervals of increase and decrease are x values. So the intervals of increase and decrease, these are x values in here. These are not coordinate points. These are x values from when x is 1 to when x is 3, from here to here. The extrema down here are minimum and maximums, local versus absolute. All right, so we have successfully analyzed a couple graphs and found a lot of the graph's personality traits. So that is what you'll be doing in today's assignment.